Welcome to the Flavor Breakdown, the place where food science gets explained simply. Shrimp starts out gray and translucent, but the moment it hits heat, it turns bright pink. That color change isn't magic, it's chemistry. Today, we're breaking down how heat unlocks hidden pigments and reshapes proteins to transform shrimp in minutes. Raw shrimp contain a pigment called astaxanthin, a deep red carotenoid also found in algae. Shrimp eat those algae, store the pigment in their shells and flesh, but in raw form it's locked away and invisible. In uncooked shrimp, astaxanthin is tightly bound to proteins that twist the pigment into a different shape. That protein-pigment complex absorbs light differently, making the shrimp appear gray or bluish instead of pink. When shrimp cooks, heat denatures those proteins, meaning they unravel and lose their structure. Once those proteins break apart, they can no longer hold on to the pigment. Astaxanthin is released and returns to its natural bright red-orange color. Shrimp proteins denature at relatively low temperatures, so the color shift happens almost instantly. That's why shrimp can go from gray to pink in under a minute in a hot pan or boiling water. Even though the color changes early, shrimp still need a bit more time for the heat to reach the center. Perfectly cooked shrimp are pink on the outside and opaque and firm throughout. Farmed shrimp get their pink pigment from their diet, just like wild shrimp. If they don't eat carotenoids, they stay pale. Like and subscribe for more food explained simply on The Flavor Breakdown.